OK, defenses. How do you stop the XSS attack? Well, the main problem, if we go back to the original XSS attacks, was that the user was providing any input that they want, and the resulting input was being interpreted as code. Now, that's not the intention. If we look at, for example, the Hello website or Google search, the user is not expected to type code into the search box. They're expected to type plain text. So the fix is to make sure that the user's input is only treated as text. Don't treat the user's input like malicious code, because we're not asking the user to write JavaScript. Instead, when the user provides some text, make sure it is actually treated as plain text. So one way to do that is to take any special characters that are used to execute code and either just delete them because the user doesn't need them, or encode them in some way that makes them harmless. So for example, in HTML, if you want to write a raw less than sign, maybe you're writing a math equation and you need the less than symbol, you can't just write less than because HTML thinks that's a tag. So instead, there's this special sequence you can use to insert a literal escaped less than character. So one thing your code can do is look for all the less than characters and replace them with this. Look for all the quotes and replace them with this special character, and do that for all of the user's input. And now, when the user inputs that script, it actually ends up looking like this. And this is not HTML. It's not JavaScript. It's just plain text with some escaped characters. So you can write this yourself, but there's already a lot of libraries that do this for you. So instead of writing your own, you can just outsource this to whatever web library you're using. Hopefully, they have some so-called sanitization library that does the work of removing all the special characters. So that's one possible defense. So turns out the fix is not as hard as it seems if we have an external library. Instead of just passing in name, maybe pass in escape string name. So I guess Golang has a function called escape string that does all the work for you. And the resulting response is now totally escaped. It will not execute as JavaScript. So it was a one-line fix all along. So the question is, why is XSS still the #1 most common attack on the web and in general, even though the fix was this simple? Well, one problem is if the programmer has to do something extra, like escape their HTML, they're going to forget to do it. They're going to forget to update their software, like Berkeley did. They're going to not know about XSS and just not do it. So we have to consider human factors. Asking humans to always implement this defense could cause them to forget or possibly not know about it. So that's one problem with escaping, and maybe why XSS is still so prevalent. Now, a more modern fix to XSS is actually something called templating. And it's kind of the same idea, but here the escaping is done for you. So for example, if you're programming a web page, some libraries just let you write HTML and then just substitute in strings like this. And whatever engine is being used to render this HTML and replace this string with the user input, it does the escaping for you. So modern web libraries, if you go and start coding web applications, they will often actually already do the escaping for you and hide it behind something like templating. That way, the users don't have to think about escaping every single time like they did here. So it's the difference between manually writing, escape, and having some library do it for you. And this is a more modern approach, and a lot of modern websites do this. But apparently not all of them, including our very own login system, which we will continually roast for messing this up.